Welcome to week 6, working problems with these precise fraction measurements. So, we'll work some problems and we'll use as much of the same language as we can that we use for whole numbers because we want to highlight this coherent whole body of mathematics that makes sense. So I'll leave a little silence here for you to think about your own language about the 9 quantities. And then again, I'll leave a little silence here for you to think about the importance of doing a bit of concrete measuring for yourself before pulling out a textbook and seeing the representations of it. So the 9 quantities and the physical doing, concrete doing of some of those measuring activities. Think about your thoughts and your language around those things. Remember, we met more units that lend themselves to fractions last week. Square yards, pounds, dollars, and meters, which actually leads to fractions, 245 thousandths, or decimals. Yeah. And then we met some more units. We met some lengths because they lend themselves to fractions, and time because they lend themselves to fractions, like hours. Minutes also lend themselves to the exact same fractions. And then different volume units, and even the angles that form a circle. This week we'll work a few problems to practice our language, again using as much of the same language as we've been using, although now our numbers have changed. Our quantities haven't changed, things that we're measuring haven't changed, the operations haven't changed. The only thing that's changing here is the value of what we measure. So we'll read a few problems. Craig has 8 flowers and 2 vases. He puts the same number of flowers into each vase. Which fraction of the flower does Craig put into each vase? I asked the same question. Who's counting and measuring? I think obviously it's Craig. And what's he counting and measuring? He's counting and measuring flowers. And how is he organizing them? He's putting them into vases. And he's putting the same number in each vase. So those are groups. So how many groups? Let's see. He has 2 vases. So how many vases? The vases are the groups. 2 of them. How many in each group? Well, if he starts to put them, there will be 4 in each group. We already know there how many in total is 8, right? So what we're looking for is how many in each group. So if he puts them 1, 2, 3, 4, 5, 6, 7, 8, we will see that there are 4 flowers in each group. But they didn't ask how many flowers. They said what fraction of the flowers. So that would be 4 out of 8. Let's hope that in the classroom, and we don't have an example of this yet, but of a set. This is a set of 8, right? And there are 4 of the 8 of them. And so how do you get 8s? I remember how we got 8s. We took like a ruler, we broke it in 2, and then 2, and then 2 again. That's how you get 8s. And you'd see that those are same as a half. All right. Ben notices that 6/8 of the shoes in a store window have laces. Who's counting? Ben. What's he counting? Laces. How's he organizing them? Let's see. Ben notices 6/8 of the shoes in the store window have laces. Oh, I'm sorry, he's counting shoes. The ones that have laces and the ones that don't have laces, right? Those are parts. So we got the ones with the laces and the ones without laces. 6/8 of them have laces. That would mean the other 2/8 don't have laces. 6/8 have, 2/8 don't, which shows the fraction of the shoes that have laces. Oh, 6 out of 8. I sure hope we've been breaking things into eighths a lot, right? Halves and fourths and eighths. So break it in two, break them into each in two more, and each in two more, and you have 6/8 so that you can see that 6/8 was the same as 3/4. Folding, folding, and folding again. Angie, who's counting? Angie. She has a box that's 3/4 foot long. What is she measuring? She's measuring the length of the box. The previous two, she was counting things, right? Now she's measuring, do you mind? Angie, what's she counting and measuring? She's measuring the length of the box. Which fraction is equal to the length of the box? In feet. Oh, good. She measured them in foot. They wanted the length in feet. That's great, of the box. And so how is she organized? She's not organizing anything. She has one measurement. It's just the measurement of a foot. She doesn't have part of it and the other part. She just measured it. It's 3/4 of a foot long. Do you know what 3/4 of a foot long is? Do you know that every fourth of a foot is 3 inches yet? So 3, 6, 9 inches. And every inch is a 12th. So 9/12. See why I like the idea of that inch being a 12th? We use 12ths a lot. All right. In a mixture of paint, 2/6 of the paint is red. The mixture contains 5 gallons of paint. How many gallons of red paint are in the mixture? Who's counting? I'm thinking it's the man at the hardware store or the woman at the hardware store that's mixing the paint, right? Have you ever seen people mixing paint? Or you could just say, I'm mixing paint, so I'm the person who's counting. And what are we counting or measuring? And so we're measuring this paint. And there's red paint. And I think there's some red paint. How many gallons of red paint? There must be some other paint too. Some red paint and some not red paint, right? If 2/6 is red, then 4/6 is not red. So there could be some parts here, the red and the not red. And they're asking about the red paint. So we're going to talk about the red part. But we have the other part if we need. And then let's see. Oh, there we go, the red and the not red. And then the mixture contains 5 gallons of paint. So 2/6 of the paint is red. And they're asking how many gallons. So let's look at a single gallon. 2/6, yeah. And so we'll group it. 1 gallon, 2 gallons, 3 gallons, 4 gallons, and 5 gallons. Can you see the gallon containers? All filled with paint. And on the bottom of each of them, it's going to be 2/6 will be red paint. And we're going to leave the other one empty to say that's going to be the other paint, because if we put the other paint in, it might mix the colors, right? So we have these 5 gallons of paint, and 2/6 of the first gallon, I can see it, 2 parts of it are red. And then in the next gallon, 2 parts of it are red. Next gallon, 2 parts of it are red. Oh my goodness, that's 2, 4, 6 parts. And each part is a 6. So by the time you get to the third gallon, I feel like you have a full gallon of paint. And then 2, 4 more. So 1 gallon and 4/6 of another gallon. Ah, which is 10/6, right? 2, 4, 6, 8, 10/6 of a gallon. Cool. I don't know why I stopped at that hole. I couldn't help myself. But 2, 4, 6, 8, 10/6 of a gallon. Nice. This is a very hard problem if you don't have those gallon containers in your head. Remember I had a bunch of them in my picture? Yeah, you got to get some of those for your classroom. All right. The table below lists the amounts of time and hours it takes 3 students to go to school each morning. So who's counting? Maybe the teacher or maybe the 3 students, they're counting. And what are they counting or measuring? The amount of time it takes to go to school each morning. So student 1 measures 1/6 of an hour, student 2 4/6 of an hour, and student 3 3/6 of an hour. And on an hour clock, right, on a clock face, I can see a 6 because I've done that. It's 10 minutes. So that first kid takes 10 minutes, 4 10 minutes, and 3 10 minutes, because I know what a 6 looks like, right? And so I'm sorry, who's counting? The students, and what are they counting? Time. And how are they organizing it? Really, they're each organizing their part, I guess. Student one's part, student two's part, and student three's part. But this time, they're not asking you to add or subtracting. They're asking you about who takes more time. So let's see. Everyone agrees that student 2 takes more than student 3. 4/6 is greater than 3/6. Student 3 takes longer than student 1. 3/6 is more than 1/6. Student 2 takes more than student 1. 4/6 is greater than 1/6. So let's see. Part A is 1/6 is greater than 3/6. Well, that's not true. 4/6 is greater than 3/6 is true. Is that true because 4 is greater than 3? Well, yeah, 4 10 minutes is greater than 3 10 minutes, so that could be it. Let's see, 1/6 is less than 4/6 because the numerators are less than the denominators. What does this mean, the numerators are less than the denominators? I didn't introduce that number, that language, but the numerator is the number at the top, 1, and the denominator is the one at the bottom, 6. The fact that 1 is smaller than 6 means it's less than a whole hour. If it was 7/6, it would be more than a whole hour. So those numbers are not greater than or less than each other because of the numerators and the denominators. The numerator being less than the denominator tells you if it's more or less than an hour, not more or less than each other. And the last one says 4 10 minutes is less than 3 10 minutes. That's just not true. So, so right here, they're grouping them in parts, but they're comparing the parts. They're not combining them. They're not finding the difference. They're comparing them. Once they compare them and you realize 4/6 is greater than 3/6, then you could ask how much bigger, and that would be a subtraction, addition, subtraction kind of problem, and it would be 1/6 or 10 minutes more. I love seeing these fractions as real things. All right. Should I leave this one for you? Who's counting? The baker. What are they counting? The number of batches and the volume, the amount of flour, the volume of flours. They're measuring it in cups. And I think they're making parts. Blueberry muffins, chocolate chip muffins, and poppy muffins. And actually, they're asking you only to record them down here. So when you, I should have put, these are called line plots, and I should have put them as ways to represent things. Yeah, ways to represent things besides number lines and circles. We could have put line plots. So let's see, we have 3 3/4. 3 3/4, 4 times 1, 2, 3, 4. So this is a possibility. This one is not, because they didn't mark the 3 3/4 at least 4 times. This picture was too big for me to fit the other 2 choices in there. But you get it. The baker's counting in parts, and they're not combining or comparing them or anything. They're only recording them. I guess you could say there are 4 groups of 3 3/4. Yeah. So they could ask you to add all of those or something. That would be interesting. There's 3 groups of 2 2/4. There's 5 groups of 3 2/4. So there's parts and there's groups, but really you're just recording. All right. I wanted to show a couple abstract ones. Just here's an expression, 5 times 1 1/12. It has the same value of which of these down here? There's no words at all, but it says twelfths. So you know what I'm thinking? I'm thinking an inch. That's a foot and an inch, right? 1 1/12, that's 1 foot and an inch. And I got 5 of them, so I'm going to have 5 feet and 5/12 of an inch. And that looks like D. Look, see my 5 feet? See my 5/12 of an inch? Or 12ths, I could think of it as like a little 5-minute section. So it's an hour and 5 minutes. Yeah? So I have 5 hours and 5 minutes, and there they are, 5 hours and 5 minutes, right down there in D. So even the most abstract representation, I can put language to, because I have some language for it. Oh, who's counting? A mathematician. What are they counting? I chose inches, feet. I chose feet and I chose hours, but you could have done anything you wanted with them. And they're in groups. There are 5 groups of them. Yeah, 5 in each group. 1 1/12 in each group, 5 groups. How many in total? Well, 5 and 5/12. Sonia rakes leaves for 3 1/4 hours. For how many minutes does she rake? So Sonia's counting or measuring, and she's measuring the time in hours it takes for her to rake the leaves. And then they're saying how many minutes does it take? So the reason I put this is because I wanted you to think about how are they grouping them. They're grouping the time You could say she's grouping like the minutes into the hours. And how many minutes are there in 1 hour? There are 60 minutes in an hour. So you could say she's counting the minutes instead of counting hours. She's counting minutes. She's counting them both, right? She's measuring time. It's not counting. She's measuring time and kind of doing it in minutes and hours. And they're asking for minutes. So maybe we're trying to count up the minutes and we're grouping them into hours. So how many minutes in each hour? 60. So there's 60 in each group. And how many groups? 3 1/4 groups. So 3 groups, 60, 60, 60, and 1/4 of 60. And if we've done that activity with the 1/4 of the hour, we will know that there are 15 minutes in there. So 3 60s and a 15, and we could add those up. So she's counting, she's measuring time, and it looks like she's measuring it in hours, but really she's looking for it in minutes. So maybe we should say she's measuring minutes. Minutes and hours. Good thing we did that activity. Let's see. We asked, so let's just review a bit. So we ask the same questions. Who's counting? What are they counting? And how are they organizing them? No matter what the problem is, whole numbers or fractions, we can use the same question. And then we say, how many in each part, or how many in each group? Same questions, fractions, whole numbers. We'll do decimals next. Guess what? So when we ask who's counting, what are they counting? We always get one of the same 9 things. Again, fractions, decimals, whole numbers, it doesn't matter. And then when we say how are they reorganizing them, we're either adding, subtracting, or multiplying, dividing. What we've noticed is sometimes we're just recording them. We're not doing either. Just plain old recording them in some new representation. Yeah? And then we say how many in each part or how many in each group. And when we answer those questions, we get whole numbers, fractions, or decimals. We haven't met the decimals yet. We'll meet them next week. So really, here it is. K-5 math in a nutshell. There's some things we measure. When we measure them, we get some numbers. And then we do something with them. We either record them, in one of the many ways we record them. Not that many. One of the few ways we record them. Then we either combine and compare them, or we make groups of them and decide how many groups we need. Welcome to K-5 Math. I hope as you read all the words in your textbook, and you read all the words in the student's textbook, and all the problems, all the different representations, you can start to see this frame around them, this very coherent view of elementary school mathematics. Have fun working some of your problems. Please practice using this language as much as you can so that when you're in your classroom, regardless of what book you're using, what curriculum you're using, what teachers you're working with, you have this language that you can bring to the classroom with you. Enjoy.